Hello, this is Professor Salahat, and in this second video, we're going to try to do problems from homework 5, and we're going to start with number 8 and go on. And in number 8, the problem here says you are given the sample mean and population standard deviation, and let's focus on the word population standard deviation. In other words, you are given sigma. Use this information to construct 90% and 95% confidence intervals for the population mean. And then they ask us to give interpretation of your answer. So for a random sample of 42, that is n equal to 42 individuals of business days, and not individuals, but business days, the mean closing price of a certain stock was, so that is the sample mean, which is 111.66. Assume the population standard deviation, which is sigma in this case, is equal to 11.24. So in this case, they gave us sigma, and we have to be careful. Every time sigma is known, we have to use z. We have to use a z to find the critical values if they are needed. We have to find z for finding the confidence interval if it's required. In this problem here, they want us to build 90 in part A. They want us to build a 90% confidence interval. So how we do that is using StatCrunch. We're going to go to stat as we did before, and we're going to go to Z-stats. And the reason is very clear why we choose Z-stat, because sigma is known. Then we're going to go to one sample, and we're going to go with summary. And again, why with summary? This is here is a summary, actually including this is a summary. So we have to use with summary. Then after that, we have to fill that summary into StatCrunch. And I'm going to show you in a sec here how we do that. So here is StatCrunch. We're going to go to stat, and we're going to go down to ZStat, and we're going to go to one sample, and then we're going to come back with summary. Let me make this a little bit big. This way we can see it better. We're going to go again, stat, ZStat, one sample with summary. And when we click on that, again, let's go back now, minimize this. This is the summary I have to the right, so I'll put it in here. The sample mean is 111.66. And the standard deviation, which is the same as sigma, is 11.24. And the sample size in this problem is 42. And we go down to the confidence interval, and we change that to 90% as required. And we compute. So let me write the answer in here. The answer we got in here, let me just round to two places, 108.81, comma, and 114.51. So that is the confidence interval that we got. So let me put this in here. It's going to be 108.81, and the second one is 114.51. This is the 90% confidence interval that we got. Now for the second part, they want us only to change the interval from 90% in part B. They are asking us to change the level to 95%, nothing else. So since I have this summary already into StatCrunch, let me go back to StatCrunch, click on options, click on edit. This information is still there. Again, we're going to use the same stuff in here. But those steps already, I did them in step 1, so just go to the edit, and the data is the same, the sample is the same, sample mean, standard deviation is the same, the number or size n is the same, just the confidence level, go down in here and make it 95%. So again, the only thing is we need to just go to the confidence level here, what I'm pointing to right now, and we change that to 95% and hit compute, and that should give us the level we're looking for, and in this, or the interval we're looking for, and the interval in this example, in the second case, is going to be 108.26 and 115.06. Now, let's minimize this window. So this is going to be 108.26 and 115.06. And I want you to notice one thing, and that is, like the question in here says, which of the two intervals is wider? Now, which one is wider? We know that the 95% is wider because think of that, we have 90 people. This is not 90%. Think of we have 90 people, and then we have 95 people. For the 95 people, we need bigger space to fit it in. So therefore, the 95 is always wider than the 90. So in this case, the 95 is wider than the 90. Okay. Now, this is similar to the problem we did before in the previous video, which in here, let's give interpretation. The interpretation here is that always it is the confidence interval is the interval, or the confidence interval is the interval decided or defined by the confidence level, okay, for the population, not the sample, the population mean. In this case, the first one, it says you can be certain that the population mean. So this one talks about population mean. It's good. Let's not finish reading. Let's go to the second one. It talks about population mean. Good. The third one, it talks about what? You can be certain that the closing price, we're not talking about a certain closing price. We talk about population mean. The last one, it talks about that the population mean. So all of those talks about the A, B, and D talk about population mean. The question will be, which one is the correct one? So let me expand this window to see the rest of this. Now in here, you say, you can be certain that the population mean, the first one, part A, of the stock is either between the lower bound or bounds of 90% and 95% intervals, or the upper bounds of the 90% and 95% intervals. That's the first choice. The second choice, you can say you can be 90% confident that the population mean price of stock is between, okay, the bounds of 90% confidence interval and 95% confidence interval for whatever. So the last choice is, it says you can, which is part D, you can be 90% confident that the population price of the stock is outside. Remember, this is wrong. D is wrong because it talks about outside. Now, then confidence interval is an interval that should capture the population mean. Okay, and when I say should, like it should 95%, let's say, can capture that. And in this case, we're talking about outside, so this is not the good answer. So we have to choose between A or B. Now, what is the difference between A and B? Let's read. You can, B, B. It says in here, you can be certain that the population mean. Certain. The second one says you can be 90% confident. Remember, we're not talking about certain, we're talking about confidence, because certain means probability, and we're not talking about probabilities. Therefore, we have to choose part B. You can be 90% confident that the population mean price of the stock is between the bounds of the 90% confidence interval and 95% for the 95% confidence interval level. So that is, again, the interval is two things. It's about population mean, and it's not a probability. It's about confidence. So when you check the answer in here, it should give us the correct answer. Now, let's look at the second one, which is number 9 in this case. In number 9, it says, if all other quantities remain the same, how does the indicated change affect the width of the confidence interval? Now, what will happen if we increase in the level of confidence? Notice that we mentioned that earlier minutes ago. If we have a 90%, then we make it to 95%. Notice that the 95% is wider than 90%. So an increase in the level of confidence, what we'll do is, what will happen to the confidence interval is going to will widen. Okay? So it will make, so if you make the confidence level bigger, you'll make the interval wider. So let's check and see if this is correct. That is correct. Now the second one, it says, okay, in part B, what if we have an increase in the sample size? What will happen to the confidence interval? Notice this one is based on this rule. Now the rule is the error is defined by Z critical times sigma over radical of n. Earlier they said that if all other quantities remains the same. In other words, don't change this, keep it fixed. Don't change the n, keep it fixed. So what will happen in this case if we increase the sample size? Now we know that if we increase this, I'm sorry, I made some slight an error in here, sorry. If this is radical n. Now in here they say if you increase the sample size, it means if you make n bigger. Notice that if you make n bigger, the square root is going to get bigger. But because the square root is in the denominator, what will happen is when you divide by a big number, you get a smaller answer. It's obvious. If I give you $100 and divide by 10 people, each will get $10. If you make the number in the bottom bigger, like 100 people, each will get $1. So when n goes up, if n goes up, what will happen in here? The error in this case will go down. In other words, what will happen to the interval? Now here is the error. When the error goes down, the error means it's going to shrink, and this means the interval gets smaller. In this case, the confidence interval will get smaller if it will narrow the confidence interval if we increase the sample size. Okay? And that is true. In other words, look at part B again. The more you survey, the closer you get to the truth. And that is exactly what we're trying to do. The more the smaller the range that you have for the truth. And by the way, the truth is mu. So mu is going to have a smaller, in other words, you're going to get closer and closer to the mu. Now, what will happen in part C? How does an increase in the population standard deviation affect the width of the interval? We can go back to the same equation in here. The error is equal to Z critical sigma over radical of n. And in here, they tell you an increase in the population standard deviation. In other words, if this population standard deviation gets bigger, if it gets bigger, that will translate to E. E is going to get bigger. In other words, what will happen in here? Here is the error. The error is going to get bigger and bigger. So what will happen to the error is going to get bigger. What will happen if the error gets bigger? The interval is going to get wider. So therefore, the interval will widen, will get bigger. Now, the next question, number 10. In number 10, it says in here, determine the minimum sample size, and we did something like this one. So they want us to find n. When you want to be 90% confidence, when the confidence level is 90%, and let me move this slightly, this way we can see the rest of the problem. Now, let's read this carefully here. It says, determine the minimum sample size. In other words, what is n required when you want 90% confidence that the sample mean is within, let me highlight this, is within 1 unit. Is within 1 unit means you are within, you can go 1 unit this way, and you can go 1 unit this way. In other words, the error equal to 1. But if the error is equal to 1, the width is going to be in here equal to 2, because 1 to the left, 1 to the right will be 2. So in this case, they gave me in the statement within 1 unit, they gave me the error. Okay? And they wanted me to use sigma equal to 14.6 if you look at back at the problem. And they want me to use yes, 90% confidence level. So how do I find that? Again, we're going to use StatCrunch. And we mentioned that in the videos before, and we're going to do it in here. So how we do that with StatCrunch, we're going to go to Stat, ZStats, calculators. Oh, I'm sorry, ZStats, one sample, sorry. and you're going to go to width, and the question is width or sample size. And why width or sample size? It's obvious because the question is asking for that. So we're going to go stat, zstat, one sample, and we're going to go down to the last choice, which is width and sample size in there. And now we're going to get this picture. In this picture, we know that the confidence level is 90%, not 95. We change it to 90. We know the standard deviation is, and again, if you look at this here, to the right, the standard deviation is here, 14.6. So we're going to put 14.6 for a standard deviation. And we know that the width is going to be 2. Again, why 2? Because they tell us within 1 unit. So you're allowed 1 to the left, 1 to the right. So the width is going to be 1 plus 1, which is 2. And when you hit compute, that's going to give you 577. So the n they are looking for is going to be 577. So you need to survey 577. Let's go down and put 577. If you survey 577, then you are guaranteeing to stay within 1 unit for margin of error. Now, if you survey less, the margin of error gets bigger. If you survey more, the margin of error gets smaller. But so it's better to survey more than 577, but it's going to cost money and time. So if you achieve or reach that 577, you can stop. Now, let me do this here, second problem, and that is number 11. In number 11, the question in here starts by telling us that a soccer ball manufacturer wants to estimate the mean circumference of soccer balls with or within, let's be careful in here, within 0.16 inches. In other words, you can be under or above by 0.16. This means that the error is equal to 0.16. This means the width is going to be equal to 2 times 0.16, or is going to be equal to, in this case, 0.32. Okay? So what else we know? In part A, they tell us determine n. N is equal to how much? Determine the minimum sample size required to construct a 99% confidence interval for the population mean. And they tell us assume, and don't forget this, assume that the population, so they mentioned the word population, that's the reason why I wrote sigma. The population standard deviation is 0.7. So in this case, we repeat the steps we did before in the previous slide or previous example. Anytime they ask us to find n, we're going to go to StatCrunch. And by the way, the window is in here, but let me just repeat the steps. You're going to go to stat, zstat, one sample, and go down to width. And then they tell us in here that they want 99%, so you make this 99%, and you need the sigma to be 0.7 because they told us to do so. And they want the width to be, remember, not the error, the width. The width is twice the error, which is 0.32. Now, when you do the math in here, it's going to give you n equal to 127. In other words, you need to survey 127 soccer balls. So 127 is needed to be tested or surveyed. In the second question, they say, they ask us in here to work, is the sample mean is, again, for second part, for part B, they tell you the sample mean is 90 or 26.9, sorry, inches. With a samples, remember in here, forget part A. They tell you for part B, start a new problem. The sample mean is 26.9 inches. So they went and sampled a total of 137 soccer balls, and they took them and they tested them and the circumference of those, and they found that the mean circumference is 26.9 inches. And they want us to build a 99% confidence interval. Now, let's build the interval, then later on we're going to go and finish answering the problem. So in here, to build the interval, I go to StatCrunch. Anytime you want to build an interval, you go to stat, Z, when sigma is known, you're going to go to stat, zstat, one sample, and with summary. Remember, we don't want now to find the n because n is given. In this case, we want to find the interval. So to find the interval, you always go to the summary. And you click in there, and let's fill in the numbers. The mean is 26.9. And the standard deviation given in this problem, and I think I missed to write the standard deviation. Let me see if I did. It says in here, if you read the problem in there in part B, it says, and the population standard deviation. So they gave me the population standard deviation, which is 0.7, as in part A. So they did not change the population standard deviation. So sigma is 0.7. So I'm going to use the 0.7 in here. And the sample size, they gave me a new sample size, which is 137. And they asked me to find the interval of 99%. So I'm going to go to 99 and hit compute. And let me just write this down in here. Here is the left limit or right limit. So the left limit is going to be 26.7. Let's go to two places, 7.5. And the right one is going to be 27.05. So let me put this down. So this is what they look for. And by the way, in here, they tell us to use two places. So in the bottom here, they tell us to use two places. So I'm going to use 26.75. And the second one is going to be 27.05. So this is the interval we get. Now, let's go back and read the question. So here's our interval, 26.75, 27.05. We know that the mean mu is somewhere between those two intervals, between those two boundaries. And we know that with confidence, we are confident 99% is going to be somewhere in between those. So if we read the problem here, it says in part B, it says here, does it seem, I'm reading in here, I'm pointing to it right now. Does it seem possible that the population mean could be less than 27? Now, can the mean here be less than 27? Again, let me move this slightly. Less than 27. Can it be less than 27? And the answer would be yes. Yes, if here is 27, and it can be here, 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 here. Yes, it can be anywhere less than 27. Yes, it can be above 27, but it can be also less than 27. So the answer, yes, it does seem that possible that the population mean could be less than 27. Because values below 27, what about them? Fall inside. There is lots of values below 27 fall inside the interval. So yes, there is a possibility that the mean can be less than 27. Let's check and see. And that is a correct answer. Now, the next one. For the next one, we're going to move to section 6.2. Okay. And again, remember, this is chapter 6.2, but homework 5 still. Now, in section 6.2, we talk about when sigma is missing or unknown, use S. Notice that sigma and S both represent standard deviation. But the sigma talks about standard deviation for a population. And the S talks about standard deviation for a sample. So this is the only difference. Now, if we are talking about sample, we use S for a standard deviation, and we use T for critical. We're going to talk about T critical. And if you look back at the videos when we cover this material, you will find when we use the T critical, we use the Z critical. So we use the T critical every time the population standard deviation is not listed. Now, if it's not listed, they're not going to list it. They're not going to tell you we're not listing it. They just tell you, they don't say anything about it. So let's look at this problem in here. In this problem, which is number 12 on your homework 5, it says, by the way, in here they just took the shortcut and say, find the T critical when or for C equal to 95% or 0.95 and N equal to 23. Now, we talked about this again, as I said in the previous videos. To find T critical, always those are the steps: stat, calculators, and you don't go to normal, you go to T. Remember, with Z, you go to normal. With T, you just go to T. And when you go to T, you're going to see a new window that will ask you for degree freedom. Remember, degree freedom is always N minus 1. If this is the N, 1, and after that, you're going to fill the last box with the C. And let's go in there. And by the way, I forget to mention something in here, which is we must use the between. Like anytime we talk about confidence levels, we have to use the between. So let me just go back to here and restart. Here is a stat. You're going to go to calculators, and when you go to calculators, you don't go to normal. Normal is for Z. You go to T. Click the T, and you're going to get this window. Make sure it's between. So I did click the between. The degree freedom is always N minus 1. In our problem here, if you take the N minus 1, is going to be 23 minus 1 is going to be 22. So we're going to use 22 into this box here. And after that, we're going to fill the last box with C. In our case, our C is 95%. So you're going to go to the last box, put 0.95. And that's all what you need to do, and hit enter. And when you hit enter, the T critical is going to be equal to 2.0739. That is the T critical that is in here in the box there. So if we go to our problem, we're going to go in here and say round to the thousands. In other words, we want you to go to 3 places. So when we go to 3 places, we're going to type in there 2.07. And before we put the 3, look past the 3, there's a 9. You add 1 to the 3 and you get 4. And if we check, it's going to give us the correct answer. Now, if you look at number 13, it says the question has been removed from this assignment. I removed the question because it's identical to the one after. So I don't want to give you 2 problems the same. So you're not going to lose any points. You'll get full credit for this. So don't worry about it. So let's move to number 14. In number 14, they gave us C, which is 0.98. They gave us S, which is equal to 2.4, and they gave us N, which is equal to 29, and they asked us to find the margin of error E. This is identical, I think, to problem number maybe 1 or 2 in your assignment. Remember, if you go back to that problem, the only difference here in that problem, they gave you sigma. Here, they gave you S. We know that by definition, the error is going to be, it is T critical or Z critical times the standard deviation, in this case S, divided by radical N. Remember, if you're talking about Z, it's going to be, if we are talking about Z, it's going to be like this. Z critical, sigma over radical N. So when we talk about Z, we put Z. When we talk about T, we put T. When we talk about Z, we put sigma. When we talk about T, we put S. So we're not going to use this. We're going to use this rule. And the reason we use this rule because S is given. So if S is given, we're going to use that rule. So how we get this? First of all, S is given. Let me just do the substitution. S is given. S is 2.4. And N is given. N is 29. The only thing missing here is the T critical. So how do I find the T critical? Let's go up. We did that. Here's how we find T critical. Stat. Those are the steps. Stat, calculators, T, and between, and degree of freedom. So let's go to the problem and do it with StatCrunch. I'm going to clear this. I'm going to go to Stat. I'm going to go to calculators, go to the right, and all the way down to T. Then I'm going to click on the between, and everything else is in front of me. The question is, N is 29. So what is the degree of freedom? Is going to be 29 minus 1, which is 28. Again, the degree of freedom is always, N minus 1. So here is N 29, subtract 1, you should get 28. And then we go back to The confidence level, which is 98%, it is given. So we hit that compute, and that should give us the Z, which is the T, 2.4671. That is the T critical. We find it here in the graph. So now we need to put this down, and we need to grab our calculator, and we need to do the math. So here is the calculator. 2.4671. That is this number. The parentheses indicates a multiplication. 2.4, and then divide by square root. Here is square, and here is square root of 29. You can do that with your calculator. If you have a different calculator or phone, either way, when you do the math, it's going to be error equal to 1.0995, and so on. So the error is going to be that quantity there. Try it with your calculator. Make sure you get it right, or your phone, basic calculator, anything you like. In this case, we need to go to around to 1 decimal place. So it's going to be 1.1. Remember, with 1 decimal place, you start counting after the dot 1 place. So it's going to be 1.1. So when we get 1.1 and we check the answer, it's going to be a good answer. Now, let's go to number 15. In number 15, they gave us C, which is 0.98. They gave us X bar, which is 13.5. They give us S, which is 0.56. And they give us N, which is equal to 15. Notice one thing. They gave us S. S is a standard deviation for a sample. That automatically tells you to use the T, not the Z. But in this case, they are not asking for an error. They are not asking for sample size. They are asking for an interval. So to find an interval, those are steps you do. You're going to go stats, and you're going to go to T stats. Look at the videos before. I talked about this a lot. You're going to go to T stat, and you're going to go to one sample. And then you're going to go to with summary. And when you go to one sample with summary, you're going to see an area we need to fill your summary. Remember, we said with summary. And notice that this is here. This is our summary. So this is the summary that we need down there. So let's go back to StatCrunch and see what we can do. Again, we're going to go to stat and go down, not Z, but a T. One sample with summary. And this is the summary. What does the sample mean? It is 13.5. That is X bar. Sample mean is always X bar. And they ask what's the sample standard deviation in this case, which is 0.56. And they ask us what's the sample size, which we said 15, which is N. And after that, they want us to build an interval. And they want us to build an interval with 98% confidence. So we go back, change the confidence to 98. That is the summary that I filled in, and that is the interval that I am getting. So what is the interval that I will get? Let me put it in here. The interval is the left. Here's the left. The left is 13.12, comma, and the right is 13.8. Remember, it says 879, so it's going to be 88. So that is the interval that we have. And when we go in here to plug those in, they want only 1 decimal place. So it's going to be 13.1, and the second place will be 13.9. You don't have to put 88. Again, they want us only to present 1 place, so we're going to put that. And if we do that, it should give us the correct answer. Number 16. Number 16, oops, the pen slipped, so we need to go back. In number 16, this is what we have. They give us an interval that goes from 6.88 to 9.54, and they are asking us to find the sample mean. Sample mean is the same as the middle here. The middle, by the way, by definition, mean is center. So which is X bar. So what is the center? The center is always the average of that left, which is 6.88, and the right, which is 9.54, divided by 2. Like if you take two tests, somebody asks you what is your average in the two tests, you're gonna add the two tests, divide by 2. So let me just do this math here. I'm gonna take the 6.88 and add the 9.54, and notice that before you divide, you hit equal. You get 16.42. Now you divide that by 2. Because if you divide by 2 before you hit the equal, you're only dividing the second number. So the mean is going to be 8.21. So that is our mean. And let's just put it in here, 8.21. So is this the correct mean? Yes. The second one is, what's the margin of error? So if this number is 8.21, the distance here is always the error. So what is the error? You're going to take the error to be 8.21 minus 6.88. And if you do the math in here on the calculator, let me find the calculator here. So this is going to be 8.21. I can use second inner, but it's fine. Minus 6.88. By the way, you can really subtract the other way around, but you have to remember, always, 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 the answer is positive. So the answer for the margin of error is always positive, which is 1.33. So we check the answer, and it tells us the correct answer. Now, this is a nice problem. In this problem, this takes us back to chapter 2. In this problem, they already gave me a list of data. And that list of data they gave me, okay, if you look towards what I'm going to point to right now, there is an icon there where I can really click on it and then open in StatCrunch, and that will take all my data into StatCrunch. So the data that you see in that table went into StatCrunch. Here they asked me to do two things, or three things. But first they asked me find the sample mean. So what is the sample mean? So we did that in chapter 2. To find the sample mean is this. Again, you can find the mean, X bar. You can find the standard deviation. Because this is just a sample. We're going to talk about S. You can find lots of things by following those steps. Stat. Then you're going to use summary stat. Okay. And let me just take it step by step. Stat and down summary stat. Then you're going to go to the column. And when you click on the column here, where it says columns, you're going to see a window. Notice that our data is already, let me move this slightly. Our data is already under variable 1. So click on variable 1. Let me move this back. When you click on variable 1, notice variable 1 is going to jump to the right. So here is variable 1, and that's all what you need to do, and hit compute. And this is a summary. Notice that in our summary, X bar that they want us to find is the same as the mean, is equal to 912. Oops. And again, it is here in the table. The mean is 912. Notice the standard deviation here, standard deviation is going to be, which is S, and the reason it is S because this is a sample of only 12 numbers. So this is going to be 304.04 something. Let's go 05. So let me go back in here. But this is 912. Check. Good. The standard deviation S is 304. How far they want me to go? 1 decimal place, 0.1. Okay. 304.1. That's all what I need. I don't need more than anything because they said they want us to go one place. Oops. They want us to go one place only. So we're going to go 304.1. Oops. Find the standard deviation. Let me go back. It says in here 304.1. is wrong. Let me just look back at it. The standard deviation, oh, not this one. I don't know where the table went. Maybe here, yes. Oh, look, I rounded wrong because look at this. I rounded 2 times because I rounded the rounding. If you look back at the table, the standard deviation is 304.04. So if I want to round like 04, let me write the whole thing and then around. 04994. So if they tell me to round to one place, the 4 in here is too small to carry on. So it's going to be 304. So let me just put that 304. 304, 304. There is no 1 in there. Sorry for that, because I looked at my rounding and rounded again. So this is very, very sensitive thing. Anyhow, then we go back to chapter 6 now, homework 5. And here they say, what is the confidence interval? Now we can go back to the steps before. Here, if you want to build the confidence interval, you need confidence level, you need mean, you need a standard deviation. Look at this, I'm pointing in here. You need this, you need this, you need this, and you need n. Do we have those in our problem? Let's see. And again, if you have all of those in your problem, you're going to go through those steps. You're going to go stat, t-stat, one sample with summary, and fill the data. So I'm going to show you an easy way to do that. And that is, let me go back in here. If data is given, when I say if data, it means if a table of data is given. Okay, to find confidence interval, do those steps. Stat, then you're going to go t-stats, and we understand why we choose t-stat, because the standard population standard deviation is never, they never wrote in the problem anything about population standard deviation. Then you're going to go to one sample. But look, in this problem here, we have the choice not to go to summary. We have to go to with data. Remember in the previous problem here, we went to with summary because the summary was given. In this problem, I can skip that and go to with data. Then after that, I can select the column that has the data, which is variable 1, and I go from there. Again, I did that earlier. I opened the data into StatCrunch. So this is my data. Now I can go to stat. I go to t-stat, t-stat, one sample, but look at this. I don't go to summary anymore. I go to data. And I tell my computer the data is under variable 1. Then after that, I'm going to go and look at the circle where it says about confidence level. And I have to identify the level that they want me to use. If we go back to the problem here, in the problem here, they're asking you to use a 90% confidence. In part C, they asked me to find 90% confidence of level. So I'm going to go down in here and change the level to 90%. And then I hit compute. And this is the interval that I have. The interval that I have is, and let me move this around. The interval is 754.37222, and the second one is 1069. Let me make this bigger. 0.6278. And if I go to the program or to the homework, they want me to write the answer to one decimal place. So I don't have to go all of those digits. 754.4, and the next one is going to be 1069.6. Now, if I do that, I will be able to get my answer. So look at this. I don't really need the mean and a standard deviation. Okay, I can use this, the data itself. The program will generate everything for me. Now, you have another choice if you want to. Somebody can say, listen, I'm not going to use the data. I already know X bar and S. So if you know X bar and S, you still can get the same answer that we get before by going to stat, T-stat, one sample, and then you go the summary. But remember, if you want to use the summary, you have to use the sample mean that you get from the calculation, and then you have to use the standard deviation that you get from the calculation, and you have to use the n, which is, by the way, if you count the number of data in the table, there is 12. There is 444, which is 12 pieces of data, and you go to the 90%, and you can do the problem here and still get the answer you get before. It's the same answer. Okay, it's the same answer. We can get the same answer, but why would we gamble in here and use X bar and S? Let's just use the data. The program is not going to make a mistake. So we can do that. Now, one more. We'll do this problem, and let's see what we have. In this problem here, it says, use the standard normal distribution or the T distribution. And again, here they're trying to trick us. They tell us use this or that. So are we going to use standard normal? So let me write this down in here in number 18. Do we use a standard normal? By the way, standard normal the same as Z, or do we use T distribution? Same as T. Which one we use? Do you use Z or T when C equal to 90%? That's what they tell us for the population mean, or for the population mean. Justify your decision. Either, if neither distribution can be used, explain why and give interpretation to your answer. So this is what we have. They say in here, in a random sample of 13 mortgages, so we are talking about n equal to 13 mortgages. The mean interest rate is, so the mean X bar, the mean is X bar. The mean interest rate, remember they said in a sample, the mean interest rate. In other words, they tell you X bar is 3.47%. And the standard deviation was 0.39%. Now let's focus on this statement again. They said the standard deviation here. Now, if you look at this carefully, they said this standard deviation did not say the population standard deviation. The word population is not mentioned when we talked about this highlighted two words in there. They say and the standard deviation. In this case, they are talking about sample. If the word population standard deviation, population is missing from standard deviation, then it is a sample. Now, if it's an S, automatically we're going to go to the T. So this will be a T, not a Z test. So it is a T test, not a Z test. And in this case, another thing we have to remember is the sample size is very small. It is obvious in statistics that when the sample size is small, we rely on T more than Z. Okay, but let's go back in here. It says, which of the distributions should be used to construct the confidence interval? Use a normal distribution? No, because standard is the same as normal. It's the same as Z. No, we're not going to use normal. Use a normal distribution. This B says use a normal distribution. No, again. Use a T distribution. In C, it says use a T distribution. In D, it says use a T distribution. In E, it says cannot use the standard normal or whatever. We cannot use any of them. Okay? And the answer is no, we can use the T. Let's try to look at C again. In C, it says use the T distribution because it is a random sample. By the way, in statistics, random is very, very important, and it says random. So the condition random is valid. And also sigma is not known. And it's true, sigma is not known. And the interest rate are normally distributed. They talk about normal distribution here. So all the conditions are available in C. Now, if you look at D, it says use the T distribution because the interest rates are normally distributed and sigma is known. And that's not true. If sigma is known, we don't use T, we use Z. So the answer should be C for those three reasons. The first one is sigma is not known. That's the condition. The other two conditions are required for anything else, and that is random sample and normal distribution. So C is our choice, and we click on C, it's going to give us the correct answer. So, oh, there is another part of this problem. So, okay, and here they say you decided, and we decided to use T. The question in here after that says, okay, then give me the 90% confidence interval. So let's go back, and we want to build the 90% confidence interval. So we have the summary here. We don't have to worry about it. Here is our summary. And we want to use a T distribution. So we're going to go in here, and we're going to, let's bring this, slide this in here. I'm going to start from scratch, stat. I said we want a T. It's one sample, and we have a summary. And what do we have? The sample mean is 3.47. Leave it 3.47. Don't convert that to a percent. Okay, because don't put it as 0.0347. And the standard deviation, I'll tell you in a minute why. And the standard deviation is going to be 0.39. And the sample size is going to be 13. And down here, the confidence level is 90%. Remember, the confidence level always has to be written as a decimal. And when we hit compute, we're going to get those. So the numbers we get in here is going to be 3.27 or 277. And this will be percent. And this will be 3.662 or 3%. So this tells you that the rate can go between those two numbers. When we talk about interest rate, the interest rate is going to be rounding between those two. And here it says round to 2 decimal places. So when we round to 2 decimal places, we're going to stop here, and we're going to stop here. So when we do the rounding in here, is going to be 3.27 and 3.66. Now, this is a question where I said I'm going to talk about this. Now, this should be a correct answer. But somebody may come back and say, no, I want to write the interest rate as a decimal, which is 0.03277 and 0.366, whatever, 3. Notice that interest rate can be expressed as a decimal or a percent. We prefer the percent over the decimal because it's easier for us to see. Like if I tell you the interest rate is 3% better than 0.03. So let's check and see if the book agree. Actually, they didn't agree with us. They want the answer to be the second one. They don't want this one. They want the second one answer, which is, I think, a dumb thing. But we're going to fulfill what the publisher of this book decided to program the computer to read. So in this case, we're just going to try to put this as 0.03. Okay, and the second, I'm sorry, I put 0.04, 0.03, and the second one is going to be point. Notice that if I one place here, this is going to be 0.03 because I'm going to stop here because they tell me to 2 decimal places, and here is going to be 0.04 because if I stop in here, that number becomes a 4. So let's put the 0.04, and hopefully they will agree with us this time. If you don't agree with us, then it's their problem. Still, they don't agree with us. Okay, use the right numbers. 90%. Let me go back. Let me start again. Stat, T-stat, one sample with summary. And they tell us, let me make sure I'm looking at those right. They tell us the sample mean is 3.47. It is in here. The sample has a mean of 3.47. So it's going to be 3.47. And the standard deviation is 0.39. And they tell me the sample size is 13. And they asked me to use a 90%. 90%. So did I? Yes. So I don't know why this is not taking the answer, because if you look at the answer here, let me just swap this up. They're not accepting any of the two answers. One answer, we can leave it as a decimal as a percent, 3.66, or I'm sorry, The first one is 3.27. 3.272161, and the second one is 3.6627 whatever. And notice that those are 2% because we left everything in percent format. Or we can put this as a decimal as 0.03277 and 0.0366 da, 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 da. So if they want us to round this answer as a percent to 2 places, this is going to be 3 point, let me write it in blue, it's going to be 3.28%, and this will be 3.66%. Now, if they want us to run this one, this is going to be 0.03, and this is going to be 0.04. So we try to put that, let me move this away. We try to put this in, and it didn't take it, and before I'm not sure what I put in. So let me just go back and try to put 3.28 and 3.66. Maybe I didn't do it the first time right, I'm not sure. 3.66. If this will not take that, then oh, it took the first one. I don't know what, did I make a mistake earlier? Let me see. 3.66 and 3.28. Maybe, I don't know. I don't know why I did. It should have worked the first time. I don't know why it didn't work. Anyhow, let's wrap up this problem. The problem here says, give an interpretation of your answer. So our answer here is telling us that between 3.28 to 3.66%, it tells us that the mean we are hunting for, we are 90, I think the problem talks about 90%. We are 90% confident that the mean, the population mean of mortgage rates is between the number 3.28% to 3.66%. So which statement is it? With 90% confidence, it can be said that the population mean interest rate is between the bounds of the confidence interval. That's a correct answer. The part B says it can be said that 90% of institutions have an interest rate, which is wrong. We're not talking about the percentage of institutions, we talk about the confidence in this case. In part C, it says if a large sample of institutions are taken, approximately 90% of them, that is the same as probability, 90% of, no, that's not. We're talking about confidence again, and neither. So the answer would be A, which is talking about confidence. So we're going to stop here, and with the next video, we're going to move into that third section. So I'm going to stop the